Hi, I'm Tisha Satapakti, and I'm a PhD student at MIT working with Professor Stephanie Mueller. I'm very excited to talk to you today about Fabricaide, which is a fabrication-aware design tool for 2D cutting machines. The main contribution of Fabricaide is to support designers who use laser cutters by doing live packing during the design phase. This is in contrast to existing tools that do so at the very end. First, I will discuss the motivation for our work. Relative to other fabrication processes, laser cutting has a pretty low barrier to entry. Designs can be made with 2D graphics software, and a lot of cutting materials can be found in local stores. But since laser cutting is a subtractive manufacturing process, it produces a lot of leftover material. Managing materials effectively is a challenge to both novice and expert users. So this motivated the question of how material management might affect the design process. To better understand this, we performed formative interviews with 6 designers who are experienced laser cutter users. And our main takeaways were that using leftover material is desirable but hard to plan around. Buying new materials is not always an option, and when that happens, designs have to be adjusted in some way. So this provided the motivation for Fabricaide, which helps users plan their designs with respect to material constraints. And I will now do a quick demonstration of our tool. This is a birdhouse design made by one of our participants in the user study. As you can see here, each of the parts are assigned different colors which correspond to specific materials that the user has. The Fabricaide UI on the right shows how the parts are placed onto the material sheets. The existing holes on the sheets are rendered in gray. So if I were to add a new shape, our packing algorithm would quickly calculate the new positions of parts for that material. Fabricaide would warn me immediately if my design can't be made with existing materials. So here, I wanted to make 4 birdhouse faces. A material warning pops up and tells me that one of my parts could not be placed while displaying the 3 parts that could be placed. It also suggests some substitute materials to try. Some advanced features include manually editing the packing, so maybe I want the shapes to be arranged in a specific way to more easily distinguish between them. And I can also create multiple copies of a design, so let's make 2 copies of the birdhouse. Of course, any subsequent changes are propagated across all copies. And since Fabricaide was not built as an add-on to a specific tool, it can work with 2D and 3D design tools with only minor modifications to the source code. Here is an example of Fabricaide working with FlatFab. To evaluate our tool, we conducted a user study with 6 designers. Each participant installed Fabricaide onto their computer and used it for about a week. Here are some of the designs that they made. Based on participant interviews, we found that Fabricaide supported different drawing workflows, helped users avoid material shortages, and encouraged material-conscious design practices. And in our technical evaluation, we found that our algorithm can pack 100 parts in just a few seconds on a budget desktop computer. And just to put the numbers in perspective, the data from our study showed that the average number of parts per user design was just 9, while the largest had 74 parts. So this goes to show that even with modest hardware, Fabricaide can perform at interactive speeds for typical user designs. For future work, we'd like to explore how our system can enable collaborative material management and see how this workflow generalizes to additive manufacturing processes, such as 3D printing. Thanks for watching my talk, and we invite you to read our paper for full details. Fabricaide is also open source on GitHub, so please feel free to try it out. If you're interested in my work, please visit my website or follow me on Twitter. Thank you.